For centuries, the open ocean has represented both opportunity and danger. It connects continents, enables trade, and allows exploration, but it also hides some of the most unpredictable forces on Earth. Among all the ocean regions that have captured human imagination, none has become as famous, controversial, and misunderstood as the Bermuda Triangle. Often described as a mysterious area where ships vanish and airplanes disappear without explanation, the Bermuda Triangle has been the subject of books, documentaries, and speculation for decades. Some portray it as a supernatural zone. Others dismiss it entirely as a myth. The truth, however, lies somewhere in between, rooted in geography, physics, human error, and the immense power of the ocean itself. The Bermuda Triangle is not an officially recognized region on any nautical or aviation map. There are no borders marked by governments or maritime organizations. Instead, the term refers to a loosely defined area of the North Atlantic Ocean, roughly bounded by Florida, Bermuda, and Puerto Rico. Despite its unofficial status, this region sits along some of the most heavily traveled shipping and flight routes in the world. Every day, cargo ships, cruise liners, fishing vessels, commercial airplanes, and private aircraft pass through this area without incident. And yet, throughout history, a series of unusual accidents and disappearances have given the Bermuda Triangle its enduring reputation. To understand why this region gains such notoriety, it is essential to separate legend from documented events. Many stories associated with the Bermuda Triangle have been exaggerated, misreported, or removed from their historical context. However, some incidents are real, and when examined closely, they reveal how dangerous the ocean can be when natural forces combine with human limitations. One of the earliest factors contributing to the Bermuda Triangle's reputation is its geography. This area sits at the crossroads of powerful ocean currents, complex weather systems, and some of the deepest waters in the Atlantic. The seafloor drops dramatically in places, forming underwater trenches and steep continental slopes. If a ship sinks here, wreckage can quickly slide into deep water, making recovery extremely difficult or impossible. The region is also influenced by the Gulf Stream, a massive, fast-moving ocean current that transports warm water from the Gulf of Mexico across the Atlantic toward Europe. The Gulf Stream can reach speeds of several knots, strong enough to push ships off course and rapidly disperse debris from accidents. This means that even when a vessel sinks near its intended route, evidence may be carried far away from the original location. Weather plays a crucial role as well. The Bermuda Triangle lies within a zone prone to sudden storms, intense squalls, and rapidly changing conditions. Tropical storms and hurricanes frequently pass through this part of the Atlantic, especially during certain seasons. Before modern satellite forecasting, sailors and pilots had limited warning of approaching weather systems, increasing the risk of disaster. Navigation technology, particularly in the early and mid-20th century, was far less reliable than it is today. Magnetic compasses, the primary navigation tools for centuries, can behave unpredictably in certain regions. While the idea of a magnetic anomaly unique to the Bermuda Triangle is often overstated, small compass errors, when combined with poor visibility, fatigue, and bad weather, can lead to significant navigational mistakes. One of the most cited incidents associated with the Bermuda Triangle occurred in 1945, involving a group of U.S. Navy training aircraft known as Flight 19. During a routine training exercise, 5 planes became disoriented and failed to return to base. Radio transmissions indicated confusion among the pilots regarding their position and compass readings. Despite search efforts, neither the aircraft nor their crews were ever recovered. Over time, stories like Flight 19 were retold with increasing layers of mystery. Details were simplified, dramatic elements were emphasized, and alternative explanations were often ignored. This pattern transformed isolated accidents into a broader narrative of an ocean region that supposedly defied logic and science. However, when researchers examine these cases using historical records, weather data, and navigational analysis, a different picture emerges. Many incidents attributed to the Bermuda Triangle occurred during storms, involved inexperienced crews, or took place in areas outside the commonly defined boundaries. In some cases, ships thought to have vanished were later found elsewhere or were misreported entirely. Still, the persistence of the Bermuda Triangle legend raises an important question: why does this particular region continue to fascinate us? The answer lies not only in the events themselves, but in what the ocean represents. Vast, deep, and largely unexplored, the sea reminds humanity of its limits. Even with modern technology, the ocean remains a force that cannot be fully controlled. The Bermuda Triangle, positioned at the intersection of commerce, travel, and natural power, becomes a symbol of that uncertainty. In this documentary, we will move beyond myths and sensationalism. We will examine the scientific, environmental, and human factors that contribute to accidents in the Bermuda Triangle. We will explore ocean currents, weather systems, navigation challenges, and the role of human decision-making. By the end, the goal is not to eliminate mystery, but to understand it. Because the real story of the Bermuda Triangle is not about supernatural forces. It is about how nature, technology, and human limitations collide in one of the busiest and most complex regions of the Atlantic Ocean. To understand why so many accidents have occurred in the Bermuda Triangle, it is necessary to look beyond stories and legends and focus on the natural forces that dominate this region. The Atlantic Ocean here is not calm or predictable. It is dynamic, powerful, and often unforgiving. One of the most influential factors in the Bermuda Triangle is weather. This region sits at a crossroads where different air masses collide. Warm, moist air rising from the tropics meets cooler air from the north, creating unstable atmospheric conditions. As a result, storms can form quickly, sometimes with little warning. Before the age of satellites, radar, and real-time forecasting, sailors and pilots relied heavily on visual cues and basic instruments. Sudden storms, dense cloud cover, and heavy rain could drastically reduce visibility in minutes. For aircraft, this meant losing sight of the horizon, a dangerous situation that can lead to spatial disorientation, where pilots can no longer accurately sense their position or movement. Spatial disorientation has played a critical role in many aviation accidents, not only in the Bermuda Triangle but worldwide. When the human brain loses reliable visual references, it can misinterpret motion, causing pilots to believe they are flying level when they are actually descending or turning. Over open ocean, where there are no landmarks, this risk increases significantly. At sea level, ships face a different but equally serious challenge. Sudden squalls and storms can generate towering waves and violent winds. Modern ships are designed to withstand harsh conditions, but older vessels, especially those built before modern safety standards, were far more vulnerable. A single structural failure during a storm could be enough to send a ship to the bottom. Another key element shaping this region is the Gulf Stream. This powerful ocean current flows like a massive river through the Atlantic, moving warm water northward at remarkable speeds. In some areas near the Bermuda Triangle, the Gulf Stream can reach speeds of over 4 knots, fast enough to significantly alter a ship's intended course. For centuries, navigators calculated their position using dead reckoning, estimating location based on speed, direction, and time traveled. Strong currents like the Gulf Stream can silently push a vessel off course, sometimes by dozens of miles. Without accurate correction, ships could unknowingly drift into dangerous waters, shallow reefs, or storm systems. The Gulf Stream also plays a major role in why wreckage is often not found after accidents. When a ship or aircraft goes down, debris is quickly scattered and carried away. What might appear to be a mysterious disappearance is often the result of natural forces efficiently erasing physical evidence. The ocean floor beneath the Bermuda Triangle adds another layer of complexity. Unlike many coastal regions where the seafloor slopes gradually, parts of this area drop sharply into deep water. Wreckage that sinks here does not settle neatly on shallow seabeds. Instead, it can slide into depths that are extremely difficult to reach, even with modern submersibles. This depth also affects underwater visibility. At great depths, sunlight disappears completely, temperatures drop, and pressure increases dramatically. locating and recovering wreckage becomes an expensive and technically challenging operation, often deemed impractical unless there is a strong economic or strategic reason. In addition to currents and depth, wave dynamics in the Bermuda Triangle can be unusually intense. Scientists have documented the occurrence of rogue waves, massive, unexpected waves that rise far above surrounding seas. Once thought to be myths, rogue waves are now well documented and known to pose a serious threat to ships. These waves can form when strong currents like the Gulf Stream interact with storms and opposing winds. The energy concentrates, producing waves capable of overwhelming even large vessels. A ship struck by such a wave may capsize or suffer catastrophic damage in seconds, leaving little time to send a distress signal. Weather systems in this region are also influenced by seasonal patterns. During hurricane season, the Atlantic becomes a corridor for powerful tropical systems. Even when storms do not directly strike ships or aircraft, their outer bands can create dangerous conditions far from the storm's center. For aircraft, strong winds, turbulence, and rapidly changing pressure systems can complicate flight paths. Early aviation technology was particularly vulnerable to these challenges. Limited fuel reserves, less reliable engines, and rudimentary navigation instruments left little margin for error. Many disappearances attributed to the Bermuda Triangle occurred during the early decades of aviation and modern shipping, a period when technology was advancing rapidly but safety systems had not yet caught up. Human confidence in new machines often exceeded their actual capabilities. Importantly, none of these natural forces are unique to the Bermuda Triangle. Similar conditions exist in other parts of the world's oceans. What makes this region stand out is the combination of factors occurring along some of the busiest travel routes on Earth. High traffic increases the likelihood of accidents, and each incident reinforces the area's reputation. Over time, these accidents were collected into a single narrative. Weather, currents, and ocean depth became secondary to mystery. Scientific explanations were often overshadowed by more dramatic interpretations. But when viewed through the lens of physics, meteorology, and oceanography, the dangers of the Bermuda Triangle become far more understandable. This does not make the region harmless. On the contrary, it highlights why caution and preparation are essential when crossing open ocean. The Bermuda Triangle is not dangerous because it is supernatural. It is dangerous because it concentrates powerful natural forces in one place. In the next part of this documentary, we will examine another critical factor: navigation. From compasses and magnetic variation to human error in decision-making, we will explore how small mistakes can escalate into major disasters, and why this region exposes those weaknesses so clearly. While weather and ocean currents shape the physical dangers of the Bermuda Triangle, navigation has always been the human bridge between safety and disaster. For centuries, sailors and pilots depended on tools that required precision, training, and constant interpretation. When those tools failed, or when humans misunderstood the information they provided, small errors could quickly become fatal. One of the most commonly discussed elements of the Bermuda Triangle is magnetism. Stories often claim that compasses behave strangely or spin without control in this region. In reality, the explanation is more subtle and far less mysterious. The Earth's magnetic field is not perfectly uniform. Magnetic north and true geographic north are not the same, and the difference between them is known as magnetic variation. In certain parts of the Atlantic, including areas near the Bermuda Triangle, magnetic variation can be small enough that compasses appear to point closer to true north than in other regions. Historically, this could confuse navigators who expected a known degree of variation. If adjustments were not made correctly, a vessel could gradually drift off course without the crew realizing it. Navigation at sea once depended heavily on celestial observation, using the sun and stars to determine position. Cloud cover, storms, or equipment failure could make celestial navigation impossible for hours or even days. During those periods, navigators relied on estimates of speed and direction, a method that accumulated error over time. In aviation, early pilots faced even greater challenges. Aircraft traveled faster than ships, leaving less time to correct mistakes. Fuel reserves were limited, communication technology was basic, and long-distance flights over open water offered few visual references. Without modern GPS or satellite tracking, a single navigational error could leave a plane lost over vast ocean with no clear point of return. One of the most frequently cited incidents in the Bermuda Triangle is the disappearance of Flight 19 in December 1945. 5 U.S. Navy training aircraft departed from Florida for a routine navigation exercise. During the flight, radio transmissions revealed that the pilots believed their compasses were malfunctioning. Confusion grew as they attempted to determine their location. Weather conditions worsened, fuel levels dropped, and communication became increasingly fragmented. Eventually, all contact was lost. Over time, the story of Flight 19 was transformed into a symbol of unexplained disappearance. However, historical analyses suggest that navigational confusion, combined with deteriorating weather and limited fuel, likely played the central role. The aircraft may have flown farther into open ocean than intended, leaving little chance for recovery once fuel was exhausted. Another widely discussed case involves the cargo ship SS Marine Sulphur Queen, which disappeared in 1963 while transporting molten sulfur. The vessel vanished without a distress signal. Investigations later suggested possible structural weaknesses and safety concerns related to the ship's design and cargo conditions. Rather than a mysterious force, mechanical failure and hazardous cargo may have contributed to the loss. Human decision-making is often the most critical factor in accidents. Fatigue, stress, and overconfidence can impair judgment. Pilots and captains may hesitate to turn back during deteriorating weather due to schedule pressure or fear of appearing inexperienced. Small delays in decision-making can place vessels directly into the path of storms or hazardous seas. Communication technology has improved dramatically since the mid-20th century. Modern aircraft carry multiple navigation systems, including GPS, inertial navigation, and satellite communication. Ships use advanced radar, sonar, and electronic chart systems that provide real-time positioning. Despite these advances, accidents still occur, reminding us that technology reduces risk but cannot eliminate it. Another factor often overlooked is reporting bias. When an accident occurs within the loosely defined Bermuda Triangle area, it receives disproportionate media attention because it fits an existing narrative. Similar incidents in other parts of the world may receive far less coverage. Over decades, this selective attention reinforced the perception that the Bermuda Triangle was uniquely dangerous. In reality, global shipping lanes and flight routes experience accidents in many regions. Statistical analyses suggest that traffic density, the sheer number of vessels passing through an area, increases the absolute number of incidents. Because the Bermuda Triangle lies along heavily traveled routes between North America, the Caribbean, and Europe, the number of recorded accidents naturally appears higher. Technology also changed how stories spread. During the 20th century, magazines and television programs highlighted mysterious disappearances without always presenting the full investigative findings. Dramatic storytelling emphasized unanswered questions rather than documented explanations. As these stories circulated, they became part of popular culture, shaping public perception for generations. Even with modern technology, navigation remains a complex task requiring constant situational awareness. Pilots and captains must interpret data, monitor environmental conditions, and make rapid decisions under pressure. When multiple risk factors align, poor weather, equipment limitations, fatigue, and navigational confusion, accidents become far more likely. The Bermuda Triangle's reputation grew not from a single unexplained event, but from a combination of real accidents interpreted through the lens of mystery. Each disappearance added to a larger narrative, overshadowing the common thread connecting most incidents, the intersection of natural forces and human limitations. In the final part of this documentary, we will bring all of these elements together. We will examine how modern science views the Bermuda Triangle today, what technology has changed, and why the region continues to capture global attention despite decades of investigation. Most importantly, we will explore whether the Bermuda Triangle remains uniquely dangerous, or whether its legend says more about human psychology than about the ocean itself. Today, the Bermuda Triangle is no longer an unknown region. Satellites monitor weather systems in real time. GPS technology allows ships and aircraft to pinpoint their exact location within meters. Communication systems provide constant contact between crews and control centers. And yet, the fascination with the Bermuda Triangle has not disappeared. Modern science does not support the idea that the Bermuda Triangle is a supernatural zone. There is no evidence of portals, unknown forces, or anomalies that violate the laws of physics. Instead, researchers see the region as a convergence point, where environmental complexity, heavy traffic, and historical limitations intersect. One important change in recent decades is data transparency. Every commercial aircraft and most ships now leave digital trails. Flight paths, engine data, weather conditions, and communication logs are recorded and stored. When incidents occur, investigators can reconstruct events with a level of detail unimaginable in the past. As a result, unexplained disappearances have become far rarer. When accidents happen, causes are usually identified: mechanical failure, severe weather, navigation errors, or human decision-making under pressure. This shift alone explains why the Bermuda Triangle no longer produces the same volume of mysterious cases as it once did. However, this does not mean the region is safe or insignificant. The Atlantic Ocean remains a powerful and unpredictable environment. Hurricanes still form. Rogue waves still occur. Ocean currents continue to move with immense force. The difference today is not the absence of danger, but humanity's improved ability to anticipate and respond to it. The Bermuda Triangle also plays an important role in scientific research. Oceanographers study the Gulf Stream to better understand climate patterns and heat transfer across the planet. Meteorologists analyze storm formation in this region to improve forecasting accuracy. Marine biologists explore deep waters to learn how life adapts to extreme conditions. Interestingly, part of the Bermuda Triangle's endurance as a legend lies in human psychology. People are naturally drawn to stories of mystery and the unknown. When something disappears without an immediate explanation, the mind seeks meaning. The ocean, vast and opaque, offers the perfect setting for such narratives. Another reason the legend persists is scale. When accidents happen on land, evidence is often visible and recoverable. At sea, especially in deep water, the environment hides answers. Wreckage sinks. Debris disperses. Silence replaces certainty. This absence of closure fuels speculation. Cultural reinforcement also plays a role. Books, films, and documentaries have repeated the story of the Bermuda Triangle for decades. Each retelling emphasizes danger and mystery, often omitting the scientific context. Over time, these stories become self-sustaining, passed from generation to generation. What makes the Bermuda Triangle truly fascinating is not the idea that it defies science, but that it demonstrates how easily human perception can be shaped by incomplete information. When natural forces, technological limitations, and narrative storytelling overlap, myths can emerge from reality. The real lesson of the Bermuda Triangle is not about fear of the ocean, but respect for it. Despite modern technology, humans remain visitors in an environment governed by forces far older and stronger than us. The sea does not need mystery to be dangerous. Physics alone is enough. Understanding the Bermuda Triangle also reminds us why science matters. By studying weather systems, ocean currents, navigation, and human behavior, we reduce risk and improve safety. Knowledge replaces fear, and preparation replaces superstition. And yet, even with answers, curiosity remains. The ocean still holds vast unexplored regions. Much of Earth's seafloor has never been mapped in detail. New discoveries continue to challenge assumptions about our planet. In that sense, the Bermuda Triangle is part of a larger story, one about exploration, limits, and the unknown. If you enjoy exploring the science behind Earth's most mysterious places, this channel is dedicated to understanding our planet through evidence, research, and curiosity. New documentaries dive into environments that challenge what we think we know, from the depths of the ocean to the extremes of the land. Because the greatest mysteries of Earth are not solved by speculation, but by asking better questions.